Hello, everyone. This is Team Space Hunters doing our technical demonstration of the CubeSat challenge. Our mission statement today is to detect large plastic debris from the ocean. These are our crew members. From left to right, it is Razi, myself, Samir, and Dylan, and we all go to Alvern High School in Hudson, New Hampshire. Today's mission is to first demonstrate the functions of CubeSat from pre-launch till detecting large plastics. I will be discussing this part. Another one is to demonstrate ground station operations, which Samir will be discussing, and to demonstrate with simulated tests detection of large plastics using recycled plastic material at home, which Dylan and Razi will be discussing. For the pre-launch test CubeSat, we first must make sure the CubeSat is functioning as designed and ready to be launched. And then we will run the pre-launch test, which includes multiple manual and automatic tests. First, we'll make sure the CubeSat built is within the mass budget limit of 3 pounds. Next, system powers up and the LED lights up, indicating the Pi is ready to perform its task. Next, confirming the battery is fully charged and solar panel is functional. Then confirming that storage space has been fully made available and remove any unwanted test data. Then confirming system is up by taking and sending a picture from CubeSat Pi camera to ground station. Finally, if ground station successfully received the photo, check the quality, size of image, and then go to edit. This is just a flow chart of the pre-launch test showing how if any single thing fails, you have to fix the issue and repeat the pre-launch test. But if everything checks off, then it's a success and it's ready for launch. This is an image of the CubeSat being weighed. It is 0.446 kilograms, which is very much under the 3 pound limit. The green light lighting up means the IMU is on, and the red light on means that the Raspberry Pi is on. Now I will hand it off to Samir.
So I'm Samir, and we're going to be talking about the pre-launch capturing test data. So we have a script called TechBot, and we called it TechBot because it's just basically the health check of the CubeSat. So what we're going to do is perform some storage space and battery level checks. And then we have a script written in Python, and that resides in the CubeSat. And we're going to take a single photo and send it to the GitHub. And then we have another script written in Python, which is at the ground station, and we're going to process the image. And then, so now we have 3 different software components that are needed to operate the mission. So the first one is the CubeBot, and this resides in the CubeSat. So that's why we call it CubeBot. And basically it takes in 2 input parameters, one being the image interval and the other one's the duration. So for example, we could have an image interval of 5 seconds and a duration of 5 minutes. So that just means that every 5 seconds, we're going to take a picture for 5 minutes. And then we're going to start by deleting the images and then scan the process according to the parameters that we have. And then we're going to push all these images that we scan to the GitHub. And then next we have the ComBot that's at the ground station. And we call this one ComBot because it's the command. It commands when we start and stop the image scan. And we're doing this by using an SSH over wireless network calls for this prototype testing. And then we have the TechBot, and that we talked about in the pre-launch session. So our CubeSat has 2 different modes of operation. One is the scan mode, and then the other one's the idle mode. So the scan mode is just communication between the CubeSat and the ground station. So the ground station is going to request to take pictures at the specified intervals. And then the CubeSat is just going to take those pictures and then push them to the GitHub. And then the next is the idle mode. And that's just going to request to stop scanning and taking the pictures to the CubeSat. And we have an idle mode just to save battery. And then this is just a flow chart of how our images get processed. So first we're going to take the picture at our specified intervals, and then we're going to process it by converting the images to from pixels to RGB values. And if we have an RGB value that's outside the threshold for it to be called water or land, then we're going to say that plastic has been detected. And then we're going to be notified, and we're going to save that to the ground station. And if the RGB values are inside the threshold of accounting it for being water and land, we're just going to say no plastic has been detected, and then we're going to delete those images to save memory space. I'm going to push it off to Dylan for the CubeSat rendering.
So this is the rendering of our CubeSat. The CAD was done in Onshape and the rendering was done in Fusion 360. We do this that way we can see how the CubeSat is put together before we actually build it, see where things go, where the IMU goes, where the Raspberry Pi, the battery, the solar panels, the camera, all of that. Here is, if I go to CubeSat, here's the actual CAD of the CubeSat. You can see it's done in Onshape. You can see the Raspberry Pi, the IMU, and all the essential components of the CubeSat. So for our simulated test plan, we want to measure the rate at which the test completes one orbit. We want to know how many pictures can be taken with minimum inputs. We also want to know how much storage space has been used in those orbits. We want to measure the time it takes to send a photo from the CubeSat to the ground station. We also want to measure the time taken to process images and decide to go into idle mode or not, or if it should go to scan mode. And we also want to verify going into idle mode and then coming back to an actual active mode of scanning mode. So this is the simulated test setup that we have made. We actually made a CAD of it. You can see, I can bring it up here. This is supposed to simulate Earth. So this curved portion here is Earth, and there's some land masses here. And then there's also some pieces of plastic littered around in the ocean. And then the back part is supposed to represent the vacuum of space. So one half of the CubeSat will be facing space. The camera portion will be facing Earth to measure what we need to measure. And also, the CubeSat will take a photo of the landmass of the plastic, and it'll measure each pixel and determine, based on the RGB value of that pixel, whether and what color it is. So if the B is a higher number, then it'll be determined to be a blue pixel. Now I can hand it off to Razi for the simulated test results.
Hi, this is Razi, and I'll be walking through the testing software, simulated setup, and test results components. So to begin, you can see that we have the putty here, and we just execute the TechBot, and it shows the memory and also the under voltage detected, which is low battery. And then moving on, we go to the CubeBot Python, and we enter the parameters 20 and 1, which means that it'll take a picture every 20 seconds in a 1 minute time interval for a total of 3 pictures. And this is the simulated test setup where you can see the CubeBot is spinning around on a swing, and we have some plastic, some dark side, and some water. And then moving on, this is where the images will be pushed to the GitHub, and we can see that it pushed the changes right here. And if we open GitHub, they will all be right here. And it managed to capture a picture of the plastic, the blue water, and also the dark side. Now we'll be going through the COMBot, and this is the Python code for the COMBot. And this is located on the ground station on my local computer. And we can see it in action right here. So these are the images that were pushed to the GitHub from the Raspberry Pi. And so first we'll just test the image with just the blue water. And we can see that it gives us the pixel count and the total pixel count, and the blue pixel count and the total pixel count match up, which gives us 100% of blue or green pixels. And this is because that was just from it being just plain water. But now if we go to the image that had the plastic in it, we can see that not all of it is blue and green pixel, and there are some other pixels. And because we entered a parameter of 10%, and the percentage of green and blue pixels is only 86, which means that 13.7% of it is plastic, and this exceeded the threshold. So going back to the simulated test results, we had a time interval of 20 seconds and a 1 minute time duration, which led to 3 pictures being taken. And the storage used was 1620 in KB. So as our summary, we have taken the feedback provided from our design review, and we incorporated it to make our CubeSat project even better. And the prototype developed used only the hardware that was provided to us and household items such as toys, cardboard boxes, swing set, and ping pong tables. And there's still a lot of room for improvement, and we'll be considering it for a final presentation for next time. And thank you so much for watching. And these are our references right here.